everybody. This is Math 025 for Hartford Community College, and this is our first module, Module 1, which deals with polynomial factoring. And this is part 1 of the video where we're going to look at what factoring is and factoring out a greatest common factor. So factoring is the process of writing a polynomial as a product of prime factoring. So factoring, factors, if I talk about those to begin with, are what you multiply together to get a number. So if I did a problem like 2 times 6. 2 and 6 are factors, and they are factors of 12, because 2 times 6 is 12. So factors is factoring is the reverse of multiplication. You're breaking it down. It's like, what did I multiply together to get that number? Here you can see we just have a couple examples or several examples. Here, I don't know why it's so small, but we have 2 times 3 times 7. All right, that's the factored form of 42, or a factored form of 42. 3x times the quantity of 2x minus 7 is the same as 6x squared minus 21x. And again, this is the factored form. It's the form that we have before the 3x is distributed. Here we have two binomials that we have multiplied together. This is the factored form, the two binomials. When you FOIL or multiply it together, you end up with 2x squared plus 15x minus 27. And then we have one other example of two binomials that have been multiplied together to give us 25x squared minus 1. And, you know, factoring, you may be like, well, most of the time in the past classes, you've wanted me to multiply it, not leave it in factored form, and that is correct. Sometimes you need it in the multiplied form, and other times you need it in the factored form. If we are going to solve for x, most times dealing with polynomials, or a lot of times, it's easier to deal with it in the factored form to find out those values of x. So factoring has a lot of uses. We're just going to look at how we do the factoring in this section. So anytime you're asked to factor something, the first thing you want to do, and this is always with any problem that we're going to factor in this class and anytime, you want to start by looking for a greatest common factor, or a GCF. So you want to look at all your terms in your polynomial. So remember, a term is connected by addition or subtraction. Or terms are connected by addition or subtraction. One single term is typically a number and a variable held together by multiplication. And you want to find the greatest common factor for all of your terms. And you want to see what is the highest number that will divide evenly into all of the numerical coefficients, so all the numbers in front of those variables. And then you also want to know what's the lowest power that is shared by all of the terms. So what's the lowest powered variable that's shared by all of the terms? So if we look here at 12x to the 4th plus 16x squared, for just the numbers 12 and 16, I know the highest number that will divide into both of those evenly is 4. So that's my greatest common factor numerically. And then with the variables, I have x to the 4th power and x squared. Because we're going to be dividing this out and we don't want to deal with negative powers, you always look for the lowest power of your variable. They both have x's, but because we have x to the 4th and x squared, we're going to choose the lower power between those two, so we would choose x squared. So my greatest common factor for 12x to the 4th plus 16x squared would be 4x squared. Okay, so here we are going to just find some greatest common factors for the given terms or constants. And for A, we have just 3 numbers here. We want to find the greatest common factor for 20, 30, and 40. Now, if you know your multiplication facts pretty well, sometimes you can figure out the number off the top of your head. Other times, you know, you may not know it off the top of your head. What I would recommend doing is taking and writing. I usually start with the biggest number. So I'm going to start with 40, and I'm going to write out the factors of 40. And I always start with, the bookends, 1 and 40. And then I work my way in. I know, well, 2 and 20 will also work. 3 does not go into 40, so I'm not going to put 3 there, but I know 4 and 10 work. And then 5 and 8, and I'm kind of running out of room there. But what I'm going to do is I'm going to look at this list, and I'm going to see, okay, well, what other numbers here are factors of 20 and 30? I know 20 is a factor of 20, so it works with 20 and 40, but 20 doesn't work with 30. Then if I look, this 10 works with 20, it works with 30, and it works with 40. And you want the greatest common factor, so I always start at the highest and work my way back. So my GCF for 10, 20, and 30 is going to, or 10, 30, and 40, excuse me, is going to be 10. My greatest common factor would be 10 there. We're going to do the same thing with B, and again, just to help us out, I'm going to list out my factors of 28. So I know for 28 we have 1 and 28, 2 and 14. 3 does not go into 28, but I also know that 4 and 7 will, and I believe that's everything. So now again, I want to find the greatest common factor for 12, 20, and 28. So if I go through, 28 works with 28, but it's not going to work with 12 and 20. 14 is not going to work with 12 and 20. 7 doesn't work with 20, doesn't work with 12, so I know that's not going to work. 4 goes into 12 evenly, 4 goes into 20 evenly, and we know it goes into 28. So therefore, that would be my greatest common factor for 12, 20, and 28. Now for C, we have all variables here. So remember, when you have a variable, you want to choose the lowest power for your variables. All 3 terms, we have x to the 6th power as one term. The next term is x to the 5th power, and then x to the 9th power is the last term. They all have x's, and they just have different exponents. We're choosing the lower of the powers, so my GCF here will be x to the 5th power. For D, they all have an a and a b in each term. So we have a cubed, b cubed for the first term, a squared, b cubed for the second term, then a squared, b squared for the third term. And what you want to look at is you want to look at each individual or unique different variable. For my a's, what's the lowest power that we have? We have a cubed, a squared, and a squared. A squared is the lowest, so I'm going to choose that for my GCF. And then I'm going to look at my b's. I have b cubed, and then b squared. So again, I'm going to choose the lowest, so b squared. So my greatest common factor for D will be a squared, b squared. All right, now for E, we have a number and a variable. So I'm going to look at the numbers first. We have 12, 16, and 20. Again, I'm going to list out the factors of 20 to help me find my greatest common factor. So for 20, I know I have 1 and 20, 2 and 10, and then 4 and 5. So I need to find a number that will go into both 12, 16, and 20. 20 obviously works with 20, but not with 16 or 12. 10 doesn't work with 16 or 12. 5 doesn't. But there's my 4. 4 will work with 16, 12, and 20. So my number for my GCF here will be 4. And then looking at your variables, all 3 terms have a t. We want to choose the lowest power, so we are going to choose t to the 2nd power. So 4t squared will be my greatest common factor there. And now we're going to look at F. For F, I'm going to do a little erasing, make some space here. 70 is my largest number, so let's list out our factors of 70 just to help us find the greatest common factor. So I have 1 and 70, 2 and 35. 3 does not go into 70, but let's see, 70 divided by 4 will not work either. 70 divided by 5 will work, and it's 14. So we have 5 and 14. 6 does not go into 70, but then we also have 7 and 10. Okay, so I know 70 is obviously not going to work. 35 will not work with 56 or 14. 14 I know works obviously with 14. Let's try 56. I'm going to divide it by 14. I get 4. So my greatest common factor here is going to be 14. And now we have to look at the variables. We have C and D in the first term, but the second and the third term, the 56 and the 70, only have C. So in order to find a greatest common factor, in order for a variable to be part of my common factors, it has to be part of all of the terms we're looking at. Since D is only in that first term, it will not be part of our greatest common factor because it's not in the other two terms. So I'm simply going to have a C as part of my greatest common factor, and it's going to be C to the, we have C to the 5th, C to the 3rd, and then C to the 2nd. So C to the 2nd. So 14 C to the 2nd will be my GCF there. So now that we have looked at factoring or finding the greatest common factor, now we are going to look at factoring the greatest common factor out of our problems or some polynomials. So again, we're undoing the distributive property. We're really taking out what has been distributed. And a polynomial that cannot be factored is going to be called a prime polynomial. So there are going to be times when you find a polynomial that doesn't have a greatest common factor, can't be factored any other way. It's primed. And what you want to do to factor out your greatest common factor is you're going to write each term as a product of the greatest common factor and another factor. Kind of what I call it is we're undoing what's been done. So we're going to take our greatest common factor, and some people write it out like this as a multiplication problem and then pull out the common one. I kind of divide it out since I know that it's there. But the big thing here is when you're factoring out your greatest common factor, never throw away your greatest common factor. You always have to put it in that multiplication problem. You can't just get rid of it because it's common to everything. You have to keep it in the problem. Otherwise, both sides of the equation will not be equal. So here we're going to look at our polynomials and factor out the greatest common factor. So for the first one, we have 6x squared plus 8x. First, I need to find my GCF. Now for 6 and 8, my greatest common factor, I know the highest number that will divide into both of those will be 2. And they both have an x, but I'm going to choose x to the first power. So that's my greatest common factor. And what we are going to do when we pull out that greatest common factor, again, you could write it as a multiplication problem. I tend to just take and divide out, because the opposite of multiplication is division, divide out that greatest common factor. But again, whatever you're dividing out of your problem, remember, you can't just throw it away. It has to be in your problem or in your answer. So I'm going to take that 2x, put it on the outside. Now, 6x squared divided by 2x is going to give me 6 divided by 2 is 3. And x squared divided by x, remember you subtract your exponents here. 2 minus 1 is 1. So I'm going to be ending up with 3x. I will keep my plus sign. Now, 2x divides into 8x. 8 divided by 2 is 4. And then remember, x divided by x, if you have the same thing on the top and the bottom, it equals a 1. So we don't need to put a variable there because it turns into a 1. So 2x times the quantity of 3x plus 4 is equivalent or the same thing as 6x squared plus 8x. This is the factored form, and this is the polynomial, or what they call sometimes the simplified form or the multiplied form. All right, now for B. We need to find our greatest common factor. We have 32 and 24. So for 32 and 24, you know what? Let's list out our factors of 32 just to look, because I know 32 can be pretty long. So we have 1 and 32, 2 and 16. 3 does not go into 32, but 4 and 8 does. And that's it, I believe. So what's the highest number that also goes into 24? 32 wouldn't work, 16 wouldn't work, but 8 does. So my greatest common factor here will be 8. They both have an a, but we're going to choose the lower power, so a to the 5th. All right, so again, I'm going to take and divide out my greatest common factor. So I have 8a to the 5th and 8a to the 5th here. All right, so again, don't throw away your greatest common factor. It has to be part of your answer. So we have 8a to the 5th times, and then parentheses, 8 goes into 24 3 times. A to the 7th divided by a to the 5th. 7 minus 5 is 2, so it'll be 3a squared. Keep my minus sign there. 8 goes into 32 4 times. A to the 5th divided by a to the 5th, again, that's going to equal a 1, so we won't have a variable there. So 8a to the 5th power times the quantity of 3a squared minus 4 is our factored polynomial. Now for D, we have 16 and we have 40. I know 16 does not go into 40, but I do know 8 goes into both, and that's going to be my greatest common factor again. They do both have s's, so it would be s to the 2nd, and they both have t's, and my lowest power is a single t. So again, I want to take and divide both of these by 8 s squared t and 8 s squared t. Don't throw away your answer, so we're going to make it 8 s squared t times 8 goes into 16 2 times. S cubed divided by s squared is s. T squared divided by t is t. Minus 8 goes into 45 times. S squared divided by s squared is going to equal a 1, so we have no s's in the second term. And t divided by t is going to equal a 1, so no t's in that second term. So 8s squared t times the quantity of 2st minus 5 is our factored form there. Let's take a look at D. We have 6x cubed minus 9x squared plus 12x. Again, my greatest common factor here, I know the largest number that will go into all three of these would be 3. And then we have x cubed, x squared, and x. My lowest power is x, so my greatest common factor here is 3x. So I'm going to divide by 3x. And 6x cubed divided by 3x. 3 goes into 6 2 times, so it will be 2. X cubed divided by x is x squared. Again, don't throw away your GCF. I'm going to put it on the outside. Minus 3 goes into 9 3 times. X squared divided by x is x. And then keep my plus sign. 3 goes into 12 4 times. And again, those last variables will equal a 1, so we don't have to write it. So 3x times 2x squared minus 3x plus 4. One thing that I want you to note, when you are pulling out a greatest common factor, you will always have a term on the outside, which is your greatest common factor. But then on the inside, if I have 3 terms to start with, my original problem, I'm going to have 3 terms in my factored form too, in those parentheses. I had 2 terms here. I have 2 terms here. So the number of terms in your polynomial that's within the parentheses will not change. They'll just be basically a smaller number because we've pulled out the greatest common factor. All right, we're going to try some more, get some extra practice. This is a good time, if you think you know what you're doing, there's our GCF, sorry. And then factored form is the third column, to practice on your own before you try it. So you can pause the video, practice these, and then come back to it if you want. But for E, we have 4y squared plus 20y minus 24. So our GCF here. Now notice for this one, this is a nice one to look at. I have y squared and I have y. But this last term is a constant term, meaning it doesn't have a variable. Because y is not in all 3 terms, it cannot be in my GCF. So here I just have a numerical GCF. If I look at 4, 20, and 24, the highest number that will divide into both, or all 3, excuse me, is 4. So that's the only thing that I can factor out of this problem. I can't take a variable out. And that's okay. Sometimes you just have a number. Sometimes you just have a variable. Sometimes your greatest common factor is 1 and you can't do anything. But when I do pull out my 4, that is going to leave me with y squared plus 20 divided by 4 will give me 5y. And 24 divided by 4 will give me 6, so minus 6. All right, if we look at F, here, I have a variable in each term, but I have x in this one, y in this one, and z in that one. None of those are common throughout the 3 terms, so I don't have a variable to pull out. 7, 8, and 9. 7 is a prime number. The only factors that go into 7 are 1 and 7. Because 7 doesn't work with 8 or 9, my greatest common factor here is a 1, which means it's a prime polynomial. We can't factor it, at least by pulling out a greatest common factor. So my answer here for my prime polynomial would just be 7x plus 8y plus 9z. I can't do anything with it right now. It can't be factored. All right, for G, we have 20, 60, and 80. My greatest common factor here, I know for numbers it's going to be 20. Now, all 3 terms have a p, and it looks like p to the 3rd power is the lowest, so p cubed. Only the first 2 have a q, so I can't include that in my GCF. So what I'm going to have to do is divide everything by 20p cubed. 20p cubed, 20p cubed, and then 20p cubed. And I know it looks a little crazy, sorry. All right, 20 goes into 20. Let me put my greatest common factor on the outside because we don't want to throw it away. 20 goes into 21 time, so I don't need to put that 1 there unless it's the only thing left. But p to the 4th divided by p cubed will give me p. And then we have q to the 4th left. All right, I'll keep my minus sign there. 20 goes into 60 3 times, excuse me. And then p cubed divided by p cubed will equal a 1. So I'm just left with q to the third power minus 20 goes into 80 4 times. And again, p cubed divided by p cubed equals a 1. So there's my final answer there. Now, with H and I, these look a little different, but they're going to get us used to what we're going to do in our next section, in the next video. And here, remember, factors are held together by multiplication. Terms are held together. Factors are what you multiply. Terms are held together by multiplication. And then to put two different terms together or terms together, you attach them together with addition or subtraction. So if I look here, this problem has two terms. The first term is 7x times x minus 1. And the other term is 3 times x minus 1. Each term is made up of different factors. So for the first one, my factors are 7. Get back on the, let me erase that. Okay, so my first one, I have 3 factors there. I have 7, I have x, and then I have the expression x minus 1. Those are all my factors for the first term. For the second term, the factors are 3, and then that 3 is held to the x minus 1 by multiplication, so my other factor is x minus 1. If you look at these 3 problems, which is our, it's not going to let me do that, is it? Sorry. All right. Which is our common factor? They both don't have a 7, so that's not going to work. They don't have a 3. I don't see an x by itself over here, so that's not a common factor. But my common factor here is this expression, x minus 1. So that's what I have to pull out of this. That's what I have to factor out of this problem. So my GCF here is x minus 1. I'm going to divide it out of both problems. So that means for the first one, and I'm going to put my x minus 1 here first, and then I'm going to put parentheses. If I divide out x minus 1 in the first term, I'm left with 7x. I will keep that plus sign right there. And then on the second one, do a little erasing here. If I divide by x minus 1, those cancel, and I'm left with 3. So my final answer, it actually factors to 2 binomials, and it's x minus 1 times 7x plus 3. So now using that same information, I want you to try to do maybe pause the video, try it. What is your greatest common factor? So now when you're looking at it, I have again 2 terms. I have a term right here. Then I have my subtraction sign, so that means that's the second term. My factors of the first term are 10q and the quantity of p to the 4th power plus 2. The second one, it's 13 times, or p to the 4th power plus 2. So there, my greatest common factor, again, is the expression p to the 4th power plus 2. So when I factor this, I'm going to put my answer down here. I'm going to have p to the 4th power plus 2. And we are going to fix that there. Okay. Factor it out here. So if I factor out p to the 4th power plus 2, I'm left with 10q. Again, if I factor out p to the 4th power plus 2, I'm left with a negative 13. So there's my final answer. What we just did is something called, or it's part of what we call factoring by grouping. We will see this again when we factor by grouping. So the last thing we are going to do in this video for part 1 is factor out a greatest common factor again. But this time, the greatest common factor we're going to pull out is going to be a -1. When we are factoring, if your leading term in your polynomial is a negative, you typically want to factor out that negative. If it's a negative like 2 or 3 or GCF, you can pull that out. But if it's just, if the greatest common factor is 1, to help you with other things, you want to keep that leading coefficient positive. So you want to factor out a -1. And really what that factoring out of a -1 will do is it'll change the signs of everything on the inside. It'll take the opposite of it. So here, if I have, for A, if I factor out a -1 from both terms, again, you don't want to throw it away, so you're going to keep that negative on the outside. Now you can write a -1, or we can just put that negative because we know the 1 is there. Two negatives, -5x divided by -1 will give me a positive 5x. So again, change the sign. 3 divided by -1 will make it a -3. So my final answer is, fix that parenthesis real quick, negative, or the opposite of the quantity of 5x minus 3. We're going to do the same thing for B. We're going to pull out a -1 there, so we're going to divide everything by -1. So again, I'm going to keep that negative on the outside. 2 negatives make that a positive 7x cubed. Positive 4x divided by -1 will give me -4x. And then -6 divided by -1 will give me a positive 6. So there's my final answer there. And then for this last one, again, divide out a -1. And I'm going to write my answer down here. I'll have my negative on the outside. On the inside, -18y cubed divided by -1 is the same as 18y cubed, or equals 18y cubed. -19z to the 7th divided by -1 will make that a positive 19z to the 7th. And -20b to the 4th divided by -1 will give me a positive 20b to the 4th. So that's what it looks like when we factor out a -1. And that's everything for part 1. Stay tuned for part 2.